Okay, so real quick recap once again. This goes into your notebook. This you're showing me, and when you get this done and you show it to me, then I'm going to hand you this right here, okay? I'm going to read this to you and give it a little bit of an explanation. This is probably the most complex thing you've learned so far in chemistry, and maybe one of the most complex things that I am going to talk about with you all year long. So please make sure that if you don't understand something that you ask about it, okay? All right. But before we do that, let's review some terms. Electron. So remember, electron has a negative charge. And what's really important for you to understand is that these are found outside the nucleus in what we call the electron cloud. And you'll notice that some atoms, I'm going to zoom in real quick, have bigger clouds than others, or some atoms have more rings, than others. And we'll talk about why that is here in just a second when we talk about the octet rule, okay? So an electron. The next thing I want to review with you is a molecule. A molecule is when we take two or more atoms bonded together. It does not have to be the same molecule, or excuse me, it does not have to be the same types of atoms, or it could be. So for instance, I could have this. These are two carbon atoms bonded together. And that would still make it a molecule. Or I can have two different types of atoms. This is hydrogen, this is oxygen, and it'd still be a molecule. However, the difference between a molecule and a compound is that in order for it to be a compound, the atoms have to be different. So let me so this would not be considered a compound. This is O2, this is oxygen. This is not a compound. This is a molecule because it has two atoms bonded together, but it is not a compound, okay? Now, if I do this and add a carbon to it, now it's CO2. That is a compound because I have different types of atoms making up this whole molecule. All right? That's important to understand this right here. You're going to need a highlighter for this. I'll make sure I leave them out. If I don't, just ask me for one or to pull them out and I'll get them for you. All right? You're not learning a song here. I just took this image off Google, so we're actually just learning the octet rule, so just scratch that word song out. Don't get confused by that. And I'm going to fold this in half. You probably should too. Put your name on it as well, and the hour in case you lose this. All right, and let's begin. So the octet rule, this is what it is. Atoms are tiny particles that make up everything around us. They are the basic building blocks of matter. This is your definition on your vocab sheet. Atoms like to be stable. I need you to highlight that. Atoms like to be stable. And in order to be stable, many atoms need to have 8 electrons in their outer shell. Highlight that as well. You got to know that. This is like chemistry 101. And we call this need to have 8 electrons in their outer ring. Notice 1, 2, 3, 4, 5, 6, 7, 8. Or right here, 1, 2, 3, 4, 5, 6, 7. It's sharing one here. Now it has 8. Okay. We call this the octet rule. All right. The octet rule says this: that atoms want to have the same number of electrons as noble gases. And noble gases are special because they already have 8 electrons in their outer shell. So let me back up real quick. So on the right side of the periodic table, there is some gases that are in green on the very edge. Those are called noble gases. We call them noble gases because they are they like to be by themselves. They don't combine with other chemicals or other elements. They are completely okay being alone, so to speak, to kind of put it in layman's terms. Okay, and so the whole idea or the whole premise for every other element on the periodic table is that it wants to be chill. It wants to be stable. Okay, and in order to do that, though, it has to have 8 electrons in its outer shell. So how does it get that, especially if it doesn't have them? Yeah? Well, let's figure that out real quick. The octet rule says that atoms want to have the same number of electrons as noble gases. Highlight that. I know I read that. Let's just highlight that. Noble gases are special because they already have 8 electrons in their outer shell. And it makes them very stable and not likely to react with other atoms. So again, I just told you that just in different terms. Atoms can get 8 electrons in their outer shell by sharing or transferring electrons with other atoms. So what that means is that if I'm an atom and I don't have 8 electrons in my outer shell, I can do one of two things. I can take one from somebody, or I can share. We can share one back and forth. Okay? And when we do that, that's actually how we get chemical reactions. When you see things smoking or fizzing or light or igniting, that's them trading electrons or actually sharing electrons, just so you know. When atoms share electrons, it's called a covalent bond. When they transfer or give them away, it's called ionic bond. And I want you to take a moment real quick, and we're going to write that at the top. Okay? So a covalent bond, covalent is when they share atoms. Ionic bonds is when they give one away. Give an atom away. In other words, they have an extra they can give. Some elements are able to give more than one atom away. Okay? For example, sodium, Na, and chlorine can form an ionic bond. Remember, ionic means give one away. To make sodium chloride, which is table salt. Sodium has 1 electron in its outer shell, and chlorine has 7. So notice 1 plus 7 equals 8. Okay. Carbon usually makes 4 bonds. Sodium has 1 electron in its outer shell. Chlorine has 7. Sodium can give its 1 electron to chlorine. Then, sodium has the same number of electrons as neon, and chlorine has the same number of electrons as argon. Neon and argon, just so you know, circle those. Oh, it tells you right here, are noble gases. So again, the goal is to be like one of these noble gases and have 8 electrons in your outer shell. Now we're ready for this paragraph. Carbon, nitrogen, oxygen, and fluorine are examples of atoms that follow the octet rule. Carbon usually makes 4 bonds, nitrogen usually makes 3 bonds, oxygen usually makes 2 bonds, and fluorine usually makes 1 bond. However, there are some exceptions to the octet rule. Some atoms, like hydrogen and helium, only need 2 electrons to be stable. Also, transition metals don't always follow the octet rule. So there's an exception to that rule, and it's hydrogen and helium. Highlight that. We'll talk about that later a little bit more. Okay? And transition metals don't always follow the octet rule either. Okay? The octet rule helps us understand how atoms bond together and form molecules, and it's useful for understanding chemistry. Okay, so just a real quick review. The octet rule says, or just explains to us, that atoms like to have 8 electrons in their outer shell. If they don't, they're either going to share them through covalent bonding, okay, or they're going to give them away through ionic bonding. And this paragraph really talks more about ionic bonding than covalent bonding. Okay. Now you know what I need you to do. I need you to answer the questions based off what we've highlighted and based off what you've read. Okay. When you get down here, I need complete sentences, 1, 2, and 3. Cool. And then come and show me. Any questions? Come and ask me. If, please, you don't understand this or just want me to explain it a different way, please come up to me and I'll be glad to do that for you. All right. Thanks so much.